Hey, John Kaverman here again with Pad Print Pros. Today I want to talk about polymer cliche making. So, polymer cliche making, some considerations, how to do it right. To begin with, you got to have a UV free environment. That means if you're using fluorescent lights, light bulbs, you need to shield those lights. You can get sleeves that fit over fluorescent tubes. You can replace standard light bulbs with UV free light bulbs. So make sure that wherever you're at, you're working in a room that doesn't have ambient light coming in windows, doesn't have any UV light in it. Doesn't mean you have to work in a dark room with red lights like a submarine. You can work under white light. You just have to shield the lights or buy light bulbs that do not emit UV. Typical light bulbs that don't emit UV are the ones that you put out there on your porch in the summer to keep bugs away, the bug lights. Those don't emit UV. That's why bugs aren't attracted to them. So in a pinch, you can work under yellow light, but you don't have to work under red. You can get tubes to slide over your fluorescent bulbs and shield them. So polymer cliches themselves. Polymer cliches have basically three layers. You have a base layer, which is steel. You have an adhesive layer, and then you have the polymer itself, which I've represented here by coloring it red. Polymer cliches can vary. The coating itself can be anywhere from maybe 30 microns to 52 microns or so. The overall thickness of this in real world is about maybe 2 millimeters in thickness, including the base, the adhesive, and the polymer layer itself. First thing that's very important in making polymer cliches is quality film. And by quality film, I mean you have a film that has a clear base, optically clear. You have the resolution you want, typically is going to be at least 600 dot per inch resolution. And you have sufficient density, density being extremely important. And that means that if you hold the film up to a light, you shouldn't be able to see the filament from the light bulb up there through the film. The film needs to be completely black and opaque, blocking all light energy from transmitting through the image area. Recommend you use offset film to achieve that density. Alternatively, you can sometimes get away with laser printed film. With laser printers, you want to set your resolution or output for 600 dpi. 300 puts a lot of toner down but doesn't give you good resolution. 1200 dpi resolution gives you good resolution but not enough toner. So middle of the road is 600 dpi with a laser printer, and then you always want to get some kind of laser toner enhancing spray, which basically you spray the film after it comes out, and that helps to make that toner more dense or more opaque. I've seen some inkjet printed film systems out there that work. They're typically the ones that are done for screen printers. They use maybe Komodo film or something like that, but those can also work. But you have to be careful. You have got to make sure density is paramount in importance. The other thing about film is that always, in every case, you want to make sure that your emulsion is on the back. This is what we call film orientation of emulsion down. That means that when you have your UV light source and your polymer cliche, the image is always on the back, so that once you put this in the vacuum frame and draw it down with a good vacuum, you're sure that you're going to have intimate contact for the image and the surface of the cliche. You don't want to have the image on top so that the film base itself can allow light to undercut and you lose resolution, line width, and all sorts of problems can occur. Always, always image on the back side or emulsion down film orientation. So what does that exposure do the first time? With the film, your image film here, you got your UV light source, and again, that image area is absorbing 100% of the UV light ideally. Where the film is clear, the light is able to transmit all the way down through the polymer base, all the way down to the base layer or the adhesive layer of the polymer, and harden from the bottom up. Polymer cliches harden from the bottom up, not from the top down. Common misconception a lot of people have is that if they have a cliche that they think is shallow, they want to increase their exposure time, and this is incorrect. That's backwards. If your cliche is shallow, it's a very clear indicator this is not opaque image area, and you're blowing some light through here and exposing the image area when you don't want to. You can test that if you have a piece of scrap cliche material or you want to test it on a plate. Go ahead and do your first exposure with film, and if you had a Elite Series photopolymer plate. That's what I call the 52 micron deep ones or thick ones. You do the first exposure and develop it, you should end up with an image etch depth right here of 52 microns, or about 2 thousandths of an inch. Now, with pad printing, you really can't efficiently pick up and transfer ink past 28 or 30 microns. So a 52 micron cliche would be too deep. Just like a 52 micron steel cliche or thin steel cliche or laser cliche, they'd all be too deep. Again, 28, 30 is probably about the limit you can pick up. So in the event that you're printing on just really fine copy, line copy, tiny little letters, you're not printing logos with anything that is bold print, you might be able to get away with what we call a one-step cliche, which is normally only 30 microns thick. With a one-step cliche, you only have to do the first exposure with the image film, and then you can go to development, which we'll touch on here shortly. But with a one-step cliche, again, they're limited just specifically for fine detail, tiny little copy, tiny little line widths, anything remotely bold or combinations of bold and fine copy. You can't use these plates because there's nothing in the image area to support the doctoring. So for these other plates, when we say that they're two exposure cliches, that means we're doing a second exposure with another film called the Linescreen film. The Linescreen film, there are different types, but for most cases in pad printing, 90% of 95% of the applications that we do, for every square centimeter, basically you have 120 line per square centimeter. 10% dot screen means that for that square centimeter, you have 120 openings, and they comprise about 10% of this square centimeter surface area. The other 90% of the film is opaque and blocking all the light. So essentially you've got, for every square centimeters, 120 little tiny openings that comprise 10% of the surface area. The rest of the film's dark and absorbs all that UV energy. So what does that do exactly? In that second exposure, the Linescreen film, represented by the dotted line right here on top of the film, again, the dots go emulsion down just like the image film does, so that when the UV light in the second exposure comes down, it goes through the holes and spreads, and essentially after it goes through and spreads, it starts to again harden the polymer from the bottom up, this time in the image area, creating a series of peaks and valleys. The peaks being the part of the photopolymer that has been exposed and hardened. The valleys are what you're removing and developing. Now in developer, if you're using water wash cliches, we recommend that you use distilled water, not tap water. Tap water, especially from municipal water systems, can include fluoride, chlorine, and all kinds of other chemicals and additives that can be detrimental to the developing process. So use distilled water. If you're using alcohol wash plates, 98% pure ethyl alcohol is recommended. You want to just, you can dilute that up to 15% with the distilled water, again, not with tap water. What you don't want to do is try to get away with going to Builder Square or Lowe's or the local hardware store and buying a gallon of denatured alcohol solvent. The reason is because that stuff is probably diluted up to 40% already with water. You don't know what the denaturing agent was. So I know it might sound expensive to buy developer at $16 or more per liter from cliche suppliers, but it's cheaper than going through a ton of plates trying to develop with something that's not going to work. So spend the money, buy the right developer from the manufacturers or distributors. So in development, once you have the right developer, you put your cliche in there. I typically use like a Rubbermaid tub so I can cover it and keep the developer from evaporating when I'm not using it. All you're doing is using a soft paint pad. That's all I use. And I do not scrub. All I do is submerge my plate and gently float the paint pad back and forth. I literally use like one finger for pressure. No scrubbing. All I'm doing is agitating, letting the chemical do the job to remove these unexposed bits of polymer from the valleys in between the mountains that I created in that second exposure with the Linescreen. So again, no scrubbing, let the developer do its job, just agitate for about 2 minutes. Once you're done with developing, you can blow the plate dry or dab it dry. Don't wipe it. You don't want to wipe those dots out because they're still soft. Those mountains that are in the cliche image area, once you remove that unexposed polymer, now the sides of those really, they haven't yet been exposed to UV light and completely hardened. That's what the post-exposure step does. UV light travels down and it hardens the sides of these mountains and makes them resilient and more mechanically resistant to doctoring. If you do not do the post-exposure step, when you put this cliche in your machine and you go across here with an ink cup, or if you have a really old machine, you're still using doctor blades, probably what you're going to do is wipe these dots right out. After a couple of cycles, you'll lose those dots and you'll be right back to having a cliche that you can't pick up and transfer a consistent ink film with because you wiped out the dots. Dots have two purposes in here. One is to support the doctor blade or doctor ring as the cup travels back and forth, and the other is to give the ink a little bit of resistance to flow so that as the doctor blade travels, you don't get all the ink going in one direction or moving around in the etch. You want it to stay down in those little valleys and maintain its shape and its resolution. The other thing is that when you take a pad and compress, you don't want the pad to kind of push ink around in the etch area, so that gives it some resistance to being pushed around by the pad as the pad is compressing on the plate. So that's the reason why we have a line screen in 95%, 99% of the cliches we make. So once you're finished with your post-exposure, the other thing that you want to do is dry the cliche to make sure that you removed all of the residual developer. So you can get a post-exposure unit dryer that does both at once. You can post-expose just by throwing your cliche back in the exposure unit without any vacuum, no film. Turn the lights on, and it's possible that just the UV lights will generate enough heat to evaporate any residual developer out of the cliche. However, you can get post-exposure unit with a dryer in it that actually has heaters and a fan that will circulate hot air as you're post-exposing with UV light, so you can kill two birds with one stone. The benefit there is that if you're making a lot of cliches, it makes a lot of sense to have a second piece of equipment to do post-exposure and drying so that you're not tying your exposure unit up by post-exposing. This step, post-exposure done correctly, when drying is 30 minutes is what they recommend. So, main points to review: quality film, you want to have good resolution. You want to make sure that the density is sufficient so that you're going to block all of the UV light from transmitting through the image area. And the orientation should be so that the image is on the back side of the film. You want to have a vacuum and a timer for your exposure unit. You want to make sure that both of your times ideally should be the same, equal for both film and line screen exposures. Your developer, again, should be, if you're using water wash cliches, use distilled water. If you're using alcohol wash cliches, use developer from the manufacturer, not the cheap stuff from the box store. Do not skip the post-exposure unit, the post-exposure step, because again, you're not hardening your plates to their full mechanical resistance if you're skipping that step and or skipping the drying step. So make sure that you're also drying your cliches. Again, post-exposure and drying should be 30 minutes. And that's it. If you have any questions, you can contact me, padprintpro@gmail.com. Check out my website, www.padprintpros.com. And I appreciate you checking out this video. Hopefully you found it helpful. And don't be shy. Give me a call if you have any questions. If email doesn't work for you, my number is 517-467-5340. It's John Kaverman signing off.